Okay, welcome to this video where we're going to be having a look at a practice paper 1 for the GCSE exam. Now you've either come to this video because you have scanned the QR code on the front of the booklet, or you found this video just on its own. If you haven't already got the booklet, I'm just going to show you how you can go about downloading that so that you can follow along with me. Now in the description for the video, and it's not this video on the screen, but this is a previous video that I did similar to this one, if you click into the description, which you can see on the right hand side, I list in there the links to download both the checklists and the booklet. So I'll show you both in just a moment, but you can find them at the top of the video. If you keep scrolling down, you'll see that I link for both tiers the series of the 3 papers. So whether you're doing the foundation papers, you'll have all 3 there, or whether you're doing the higher paper, you'll have all 3 there. Below that, I always list some useful videos for revision, along with my everything you need videos for both of those tiers. And if you keep scrolling all the way down, you'll see there that I've got the timestamps for every question in the video with the full lesson next to that, so you can click in at any point and watch a full lesson on that particular topic. Really good if you are finding one of the questions a little bit tricky. You can go in and you can practice some more similar style questions and obviously access a full lesson on that. So everything's there. It's really easy to use. You can use the chapters feature as they're all timestamped. You can click into the chapters on the start of the video just by clicking on the screen and clicking that word there where it says where we're at, and you can flick through the booklet having a look at different topics along the way. Always good if you don't want to watch it all in one go as well, because you can just jump back and access the question that you got to. So loads of stuff that you can do there. So before we get started on the video, I'm just going to show you the checklist. So here is my checklist that you can obviously download from the description. It's all in there for you, but I just want to show you some rationale behind this particular paper. So obviously across the 3 papers there's a lot of topics that can be included. Now what I've done is I've just gone through and I've picked a good selection of different topics that tend to appear on a paper 1 and a couple of topics that tend to be quite tricky ones that tend to appear on a paper 1 as well. So you'll see that over on the right in the trigonometry section we've got some exact trigonometry in this video. We've also got a couple of topics like speed, distance, time in that ratio and proportion section that are quite tricky ones to appear on a non-calculator paper. But across the 3 papers you will have a good variety of all of these topics, so I do recommend that you make sure you are subscribed to the channel and you are watching out for those other papers if they haven't already come out. By the time you're watching this, all 3 of them may already be out and you can access them as I showed you in the description. So there we go, that's the rationale behind how we are going to approach the topic. As I said, all of this can be downloaded from the description, so do go and download that, get it printed off and use that for your revision. But without further ado, let's get started. Okay, so let's get going. As I said, when you get this booklet, of course, on the front there you will have a QR code, so you can always scan that and you can get straight back to this video. So if you've got it downloaded, it's very quick to find the video that you need to get back to obviously practice some of these questions. As I said as well, there is no guarantee that these are going to be the exact topics that appear on your exam. They are just a good selection of topics that tend to appear and are common questions that appear on a paper 1 exam. So don't use this as your only source of revision. Make sure that you check out all the other videos to get a good coverage of all of the topics that tend to appear on paper 1 exams. But we're going to get started with question 1. So it says here, write the following numbers in order of size, start with the smallest number. We've got some negatives involved. So we want to get that biggest negative to start with, so we're going to start with that -3 and then go for our next negative, which is -1. Then we've got 0. Then we've got 2, and then we've got 4. So that's all just about having a good understanding of a number line. So hopefully a nice easy question. These starting pages are all about building your confidence at the start of the exam. So just make sure that you don't rush these, particularly for those of you that are, very focused on those grade 4 and 5 topics. Don't neglect these questions at the front. It's much easier to pick up the 1 mark on the first page than it is to gain that 1 mark at the end of the paper. So just make sure you approach these really nice and carefully. So write 3/5 as a percentage. Well, if we want to write a fraction as a percentage, ideally we want the denominator to be over 10 or over 100. So 3/5, we can easily make that over 10. We can easily make it over 100, but we can very easily make it over 10 by timesing them both by 2. So that would be 6 over 10, and 6 over 10 is 60%. Of course, if you want, you can write that over 100, which is 60 over 100 as well, and that would just come out as 60%. Okay, on to the next one. Write down a factor of 60 that is between 8 and 14. So factors are numbers that go into 60. So it might help by writing out some factor pairs. Well, 60 is 1 times 60. Neither of those are between the numbers we want. 2 times 30. 3 times 20. None of these are meeting our criteria yet. 4 multiplied by 15. That's not the nicest. You've got 5 multiplied by 12. And we've just hit one there that falls in between our 8 and 14, so 12 works. 15 was slightly too big, none of the other numbers fell in between. So our answer there would be 12. Let's have a think, are there any other factors maybe? So you could have had 6 times 10, so 10 would have been absolutely fine as well. That's between 8 and 14. 7 doesn't go into 60. 8, does 8 go into 60? If you're not sure, I mean, we've already got one, so we don't really need to don't need to worry about this. But does 8 go into 6? No, it goes to 56 and then goes to 64. So 8 doesn't go in. So they are all the factors of 60 there. So you could have either had 10 or 12. Don't write down both of them. It says write down a factor. It doesn't say write down all the factors. Just make sure you read the question carefully. If it said write down 2 factors, then we'd write down 10 and 12. Write the following numbers in order of size. Start with the smallest number. Well, it can always help to balance these out so they've all got the same amount of decimal places. So 0.4, this one here has 3 decimals in. So if I add 2 zeros to the end of that, another 0 to the end of this one, and 2 more on the end of that one. Now you can just read the number after the decimal point. So what I mean by that is if we read this one, we've got 400, this one's 20, 370, 152, and 200. So you can just kind of order them by reading the numbers. We want to put the original ones in. So start with the smallest, that was our 20, so that would be number 1. So that was 0.02. The next smallest number was 152, so this would be our second, so 0.152. Then our next smallest is the 200, this one here, or 0.2, so 0.2. Then we've got the 370, that'll be our fourth, so 0.37, and then our final number is that final one, 0.4. So there we go, just going through those carefully. Again, around about the speed that I'm doing it, you don't want to be rushing these earlier questions as we've already mentioned. So for this next one, simplify 2m times 3. Well, when you are multiplying with algebra, numbers multiply by other numbers, so the 2 multiplies by the 3 and you get 6. So we're definitely going to have 6. And then the letter, which in this case is m, would multiply by another letter if our 3 had one, but it doesn't. So we just keep the m on its own, and that'd be our answer. Remembering if there was like another m here, then that would turn into an m squared. Or if there was another letter here like an n, then that would be 6mn. But there we go, we didn't have any other letters with that one, so just 6m is our final answer. Okay, on to our next one. Here are 4 numbers. Write one of these numbers in each box to make a correct calculation. There's normally 2 or multiple different ways of doing this, but let's have a look. So to get to -7, well, we could start with -9 and we could add +2 to that. So -9 add 2 does equal -7. Now what I mean by there could be other answers here is that you could actually add the negative to the 2. So we could have 2 plus -9. And that plussing the negative or adding the negative would be a takeaway. So it'd be 2 take away 9, and that 2 would equal -7. So you could have -9 and 2, or 2 and -9. And there we go, 1 mark for that one, but either one of those answers. Right, so the incomplete pictogram shows information about the number of wheels sold in a shop on Tuesday, on Wednesday, and on Thursday. And we can see that just here, we've got Tuesday, Wednesday, Thursday. A total of 20 wheels were sold on those 3 days, 8 wheels were sold on Friday, and 15 wheels were sold on Saturday. Use this information to complete the pictogram. Well, the key bit of information we have here is that 20 wheels were sold on those 3 days. So when we're looking at creating this, our pictogram here, we want to think about creating a key. We've got a blank box for the key there. So let's think about how many wheels we have here. Well, we've got 1 wheel here. Then we're up to, and I'm going to do this cumulatively. So 2, 3, I'm going to count this whole one down here, 4, and then these 2 would make 5 wheels. So in total, we've got 5 wheels, or 5, I'm just going to write this here, 5 wheels equals 20 actual wheels. I should probably, instead of writing 25 wheels there, I should draw this picture. So 5 of those equals 20 wheels. So one of those wheels, if we divide that by 5, one of these would equal 4 wheels. And that's what we're going to put into our key. So if we put a key here, one of these wheels, little crisscross in there, is equal to 4 wheels. And that's going to allow us to go across and we could say how many wheels were sold on each day. This one would be 4 wheels, this is one of them. We've got 4, 4 and half a wheel, so that would be 2, so that would be 10 wheels. And this is going to be 4 and another half there, so that would be 6 wheels. So 8 wheels were sold on Friday, so we would have another 2 of those, that's 4, and there's another 4, so that's 8. And 15 wheels were sold on Saturday. Well, let's start putting a load in because that's going to be quite a few. So 4, 8, 12, and then we want another 3, so that's going to be 3/4 of a wheel, and that's always quite awkward to draw, so you're going to have to make sure you draw this really neat. There we go, that looks like a good 3/4 to me. And there we go, so that would be 4, 4, 4 and 3. So add those up, that's 15. So there we go, that's completed the pictogram. And there we go, and we've put our key in there to make sure that is completed as well, because that is part of the pictogram. So if that's blank, we do need to fill it in. There we go, there's our pictogram question. Write down an example to show that each of the following 2 statements is not correct. There we go, so they're definitely not correct, we just need to prove that. So the factors of an even number are always even. Let's write down an even number. What about 10? 10's got a couple of factors, so let's see if that works. So 10, the factors are 1 times 10 and 2 times 5. Well, it said if the factors of an even number are always even, well, no, of course they're not. For starters, 1 goes into every number, and that's not even. And for 10 here, look, 5 goes into 10, and that's not even. So write down an example. How could we write this down? So we could write 1 times 10 equals 10, and you could write 1 is odd. Okay, or any other combination of that. You could write 5 is odd as well. All the digits in an odd number are odd. Well, that's definitely not correct, is it? Because let's just think about anything that starts with an even number, like 20 and 21, 23, any of those, 23, that's an odd number. That's an odd number, but the digit 2 is even. Okay, so we could write something like 23 is odd, but we could even point at it if we wanted. 2 is even. There we go. And you just want to make sure that's really nice and clear what you're actually talking about. They're normally quite obvious in terms of creating them. It's actually normally thinking about how do I go about actually describing that, particularly on a small dotted line, to show that that is incorrect. There we go, so hopefully that's nice and clear there. So Amy spins a spinner, or a fair 8-sided spinner. On the probability scale, mark with a cross the probability the spinner will land on a C. So if we look at the actual spinner, C is here, here, here and here. It's an 8-sided spinner and there are 4 C's on there. So that's half of the actual letters is a C. So it literally says half right there, so we want to put a big cross on the half. That's the probability it will land on a C. For part B, on the probability scale, mark with a cross the probability the spinner will land on a D. Well, if we go back up, there are no D's on the spinner. We've got 3 A's, a B and 4 C's. So it's literally impossible to actually land on a D. Impossible on our probability scale is the number 0. So we're just going to put a big cross on the number 0. And there we go. You've got a few other positions on your probability scale. You've got places here which are likely, or unlikely, sorry. You've got places here that are likely. So you've got a few little words that can come into play there as well. They're unlikely, and these are places that are likely. But you could obviously break that down into sort of a more mathematical, sort of fractional portion as well. So for example, on this spinner, B appears 1/8 of the amount of times. And 1/8, if you were to break this down into sort of smaller chunks, you can actually get it more mathematically correct if you were going to try and draw them a little bit more accurately. But there we go, that's how you would approach a probability scale. Dave goes into a cafe and buys 2 cups of coffee and a piece of cake. Each cup of coffee costs £2.75 and the cake costs £2.90. Dave pays with a £10 note and he thinks he'll get more than £1.50 in change. Is he correct? And show how you get your answer. This is important, you must show how you get your answer. So we're not going to assume that any of the numbers we write down, the examiner knows how we've actually got there. So for this we're going to get 2 cups of coffee, we're going to times that by 2, and the cake, we're going to times that by 1, which we've already got, so just one piece of cake. So if we add those up, we've got £2.75, another £2.75, and £2.90, and add those all together. So 5 and 5 is 10, 7 and 7 is 14, plus the 9, 23, plus the 1, 24, carry the 2, and then 2, 4, 6, 8, and that's £8.40. So in total they add up to £8.40. Now you can probably see in your head, if we're paying with a £10 note, as it says just here, well, we're going to get £1.60 change. But we must show how we get our answer. So I'm going to write 10 take away £8.40, and that is equal to £1.60. So he thinks he will get more than £1.50 in change. Is he correct? I'll say yes. He gets £1.60. There we go. And that has shown how we got our answer, and we've given our conclusion there and answered the question where it says, is he correct? Yes, he is correct. On to our next question. So here's a list of 4 fractions. One of these fractions is not equivalent to 1/4. Write down this fraction. Well, 4 over 16, if you divide the top and bottom by 4, we get 1 over 4. 2 over 8, if we divide the top and bottom by 2, we get 1 over 4. Okay, we're getting there. This one, if we divide the top and bottom by, it's not actually, I've just spotted if you divide by 15, I was going to divide by 5, but if we divide by 15, again we get 1 over 4. So it's definitely going to be this last one. If we divide those, we can only divide by 3, and you get 1 over 3. So the fraction that's not equivalent to 1/4 is 3 over 9. And there we go. Work out, and we have to do a takeaway here of the fractions. It doesn't say anything about simplifying the fractions, but if we're going to take away fractions, we need to get a common denominator. So to do this, times the left by 5, the right by 3, and that's going to give us a common denominator of 15. So the numerator on 2/3 will become 10, the numerator on 1/5 will become 3, and when you take those away, you get 7 over 15. And there we go, 7 over 15 will be our final answer. On to the dividing fractions. Well, that's where we multiply by the reciprocal, in other words, times by the flipped version of the second fraction. So 4 over 3 instead of 3 over 4, and then really nice and easy, you just times the top and times the bottom. So 2 times 4 is 8, 3 times 3 is 9, and there's my final answer, 8 over 9. And there we go, there is dividing fractions. Okay, on to our next one. So we've got some solving equations. So this first one, m plus m plus m is 12, and you can use a logical approach to that. You could collect like terms, and you could say, okay, well, 3m equals 12. And then we hopefully know when doing that, divide by 3, and we get m is equal to 4. So there's our final answer, m equals 4. Or we could just put the number 4 for this one. For the next one, something divided by 2 is equal to 6. Or to reverse that, whenever you've got a divide in a fraction, the opposite is to times. So if we multiply both sides by 2, we get x is equal to 12. And that's quite a logical question anyway, because this number on the top here, you just have to think what divided by 2 equals 6. That is 12. So there we go, x is equal to 12. Come to our final question. We've got a 2-step equation. So when we've got this, we need to first do the inverse of that plus 2. So taking that away, so 6n will equal 18, and then divide by 6, like we did in part A there, when we divided by the number that's stuck onto that letter, so n will equal 3. And there we go, n equals 3. And just as a little side note, if that number there didn't divide perfectly, so say for example we had 5n equals 18, then you could write that as a fraction. You could write n equals, and I will keep it as 6, but we'll write 18 over 6, and that'll be fine if it didn't divide. But if it does divide, you do want to write what 18 divided by 6 actually equals. But there we go, there is some of our equations. Okay, on to a picture sequence. Now whenever I see a picture sequence, I always write this in terms of their numbers. So this first one has 1, 2, 3, 4 dots. The next one, 1, 2, 3, 4, 5, 6, 7 dots. So I can straight away see it's going up in threes. I'm going to check the last one though, just in case it's a form of special sequence. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 dots. So my pattern goes 4, 7, 10. And if I'm going to write the nth term of a picture sequence, I just want to see what's the difference between. It goes up in threes. So this is the 3 times table, which we write as 3n. But this is bigger than the 3 times table. The 3 times table goes 3, 6, 9, and all these numbers are 1 bigger. So it's a 3 times table, but with 1 added on, and that is 3n plus 1. And there we go, there's how we approach a picture sequence. It says here, Kira has 90 counters. Can Kira make a pattern in this sequence using all 90 counters? And you must show how you get your answer. Now what you could do, it'd be a very slow way of doing it, but you could just keep adding 3 onto your sequence. So after 10, we'd have 13, 16, 19, and we'd just have to keep going and see if we hit 90. It'd be a very, very slow method, but if you were really unsure about this, that'd be your fail-safe method if you had a few minutes left at the end of the exam. But here we go, we want to find out a quick mathematical way of finding the 90 counters. So we can do this just solving an equation. We can say, well, our nth term is 3n plus 1. Does that ever equal 90? And that is forming an equation. We now just need to actually solve that. So take away 1 from both sides, you get 3n is equal to 89. At this point now, we would need to divide by 3. And you'll hopefully spot that 89 doesn't divide by 3. So 8n would equal 89 over 3, and that's not a whole number. So the answer would be no. No. And you could just write 89 divided by 3 is not a whole number. There you go. Or of course, if you wrote your sequence going up in threes, you could write the 2 numbers either side that actually showed that 90 was in the middle. So completely up to you which method you use there. This method's just a bit quicker, and obviously you need to be able to solve equations anyway, so you may as well use that method there. Okay, question 14. Write down the value of the square root of 64. Well, what number times itself is 64? That's 8 times 8. So the square root just equals 8. So there we go, that'll be our final answer. Square root is 8. Look at the value of 5 cubed. That is 5 times 5 times 5. You can do that in little stages. 5 times 5 is 25, multiplied by another 5, and that is 125. So there we go, 125. Final answer for that one. A couple of nice little 1 markers there thrown in the middle. So Nasmin is going to use these instructions to make a fizzy drink. Nasmin thinks that she has 300 millilitres of apple juice and 200 millilitres of lemonade. If Nasmin is correct, what is the greatest amount of fizzy drink she can make? Well, 5 to 2 is our ratio. 5 parts apple and 2 parts lemonade. So here we've actually got 2 different options. We could either make this drink using all 300 ml of apple juice, or we could make the drink using all 200 ml of lemonade. Or maybe they're already in the correct ratio and we can use all of them. But that's unlikely. So looking at this, if we use 300 ml of apple juice, then how do we actually get there? Well, to get from 5 to 300, if I forget about the 0 for a second, how do I get from 5 to 30? That's timesing by 6, so that must be timesing by 60. So timesing by 60, and we do that to both sides of the ratio, and that would give me 120 millilitres of lemonade. So in that scenario, if I use all of the apple juice, then I would need 120 millilitres of lemonade, and she thinks she has 200, so that would work. We've got plenty there. But what about the other scenario? So apple to lemonade is 5 to 2. If we had 200 millilitres of lemonade, then how would we get to that one? Well, to get from 2 to 200, that's a bit easier, multiplying by 100, and we'd do the same to the other side, and that would give us 500. Now you can already see here that if that's 500, then that's not going to work, because she says she only has 300 ml of apple juice. So this scenario here does not work, as we don't have enough apple juice to use all the lemonade, but this one over here does. So this is the scenario that works. So if she is correct, she can have 300 ml of apple juice, 120 ml of lemonade, and together 300 plus 120 would give her 420 millilitres of the fizzy drink that she's going to make. So there we go, a little bit of a different kind of question there. If we turned this statement into a ratio, so 5 to 2 for the apple to lemonade, and then we tested out two different scenarios using all of the apple juice or all of the lemonade. And obviously reading the question carefully, the greatest amount of fizzy drink. So not the greatest amount of lemonade or the greatest amount of apple, but the greatest total when combining the two. So Nasmin has 300 ml of apple juice, but she only has 160 millilitres of lemonade. Does this affect the greatest amount of fizzy drinks that she can make? Give a reason for your answer. Well, that wouldn't have any effect, because 160 millilitres of lemonade is absolutely fine, because we only needed 120. So we would say no, we only needed 120 millilitres of lemonade. And we could say, so there is still enough, something like that. So there is enough. There we go, final answer. Okay, so on to our next question. Work out an estimate for 790 times 289 over 49. Now this is an estimate, so we're going to round these numbers to one significant figure. You can round them more accurately than one significant figure, but you're going to get full marks for just doing one significant figure, so I never see the point in doing that. So here 790 to one significant figure is 800. 289 to one significant figure would be 300, and we're going to divide that by 50. Now of course you could do 790 multiplied by, and to two significant figures, 289 would be 290, but then why bother? Because this is a lot easier and you're going to get full marks for doing one significant figure anyway. So to work this out, really nice and easy to do, you just do 8 times 3, which is 24, add on all those zeros, so 4 zeros, and we're going to divide by 50. Now again, really nice when you're dividing by something like this, because I can just cancel off one of the zeros top and bottom, so instead of dividing by 50, I can divide by 5, I just need to get rid of one of the zeros on the top. Essentially what we're doing is we're dividing the top and bottom by 10, and we're now just going to do 2, 4 with 3 zeros, so what's that, 24,000 divided by 5. Now you still need to get this accurate, so I'm going to do some bus stop division to the side. 5 into 24,000, 5 goes into 20, 4 times, remainder 4, it goes into 40, 8 times, and then we've got 2 zeros there, so our final answer would be 4,800. And there we go, there's some estimations. Okay, on to some transformations. Describe fully the single transformation that maps shape A onto shape B. You've got 4 types of transformations. You've got a translation, you've got a reflection, you've got a rotation, or an enlargement. And hopefully you can recognise that this is a reflection. So you just need to find the reflection line. But before we do that, we'll write reflection. And then we just need to find the line. Now for this one, the reflection line there is along this line here. Look, there's the same amount of space from there to there. And there's the same amount of space from there to there. So that is a reflection. And this line here, as you can see, it is labelled for you, is called the x-axis. There is another way of describing that line. You can say y equals 0, but I never see the point in overcomplicating it there when we've always called it the x-axis. So reflection in the x-axes. There you go, you've got 1 mark for reflection, 1 mark for the correct line there. So it's a reflection in the x-axis. Right, on to our next one. On the grid, draw an enlargement of the shaded shape with a scale factor 3. A scale factor 3 means all the sides are going to get multiplied by 3. And this is a bit of an awkward shape. Let's have a think about how we do this. Now what I can see is that I want to do the straight lines first. These ones that are sort of diagonal and go across multiple squares, they're very awkward to do. So let's do this one to start with. So that's 2 across, and that, or 2 up, and that's 2 across. So if we times them by 3, that'd be 6 and 6. So if I start drawing it in, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I'm happy with those parts. I just need to find where this coordinate here is going to go. Okay, so if we think about this in terms of a movement, from this little point here it goes 1 up and it goes 3 across to get to that point. So if that's 1 up and 3 across, if I want to do that obviously multiplied by 3, then from this top point here I'd have to go 3 up and 9 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that would end up there. There we go, so that would be the same movement but multiplied by 3. So that was to get from this point here to this point here. So that's not the nicest of ones to do, but now I can join that up, obviously using a pencil and a ruler. Join it up from here as well. Don't need to do that final side as long as I'm confident that I've got that one. And there we go. And that'd be a really awkward shape to have on the exam. That'd be a really awful one to have to mark as an examiner, because that can be drawn anywhere, and that would be absolutely awful to have to try and count. There we go. But there is the size of the shape. That is drawn to a scale factor of 3. Obviously these straight edges, the ones that turned into 6, these were nice and easy to do. It was just finding that coordinate there by doing that movement. And there might be other ways that you could have done it. You could have done it from this bottom right here, gone 1 across and 3 up. That was completely up to you. But there we are. There is doing an enlargement. Okay, so some simple interest. It says Dave invests £400 for 5 years in a savings account. The account pays a simple interest rate of 3.5% per year. Work out the total amount of interest that Dave gets. So be very careful. I'm going to highlight that because that doesn't mean it wants the total amount. It just wants the total amount of interest. I don't want to forget that in the final step because you would lose a mark for that. So simple interest, we get the same amount every year based on whatever you get in the first year. So if I work out 3.5%, I'd always start by getting 1%. You could start with 10% and then break it down that way if you like. But 400 divided by 100 would give me 4. So 1%, I'm going to get £4. I want another 0.5% as well, because I want to make 3.5%. So 0.5% be half of that, be 2. So to get 3.5%, I want 3 of those, and I want 1 of those. So 3 times 4 is 12, plus the 2, and in total, that's £14. So every year, we're going to get £14. It says in the question that we're going to get that for 5 years. So if I times that by 5, 5 times 10 is 50. And again, you could obviously do your working out to the side. You don't want to get any of these wrong. 4 times 5 is 20, so it's going to be £70. But 5 times 4 is 20. 5 times 1 is 5, so £70. So for this answer here, you are going to get £70 interest over those 5 years. And there we go. If it said how much money does he have in the bank, well, in that case you'd do 400 plus 70, and your final answer in that question would be 470. But the interest part is just that £70 there. So he's made a total of £70. There we go. So there is your simple interest question. Moving on to some angles, we've got some parallel lines, we've got a triangle, and we've actually got a quadrilateral here. If we look at it this way, you've got a quadrilateral in that trapezium. So let's have a think about how we go about this. So AED and ABC are straight lines. EB is parallel to DC. Work out the size of BAE. Where's that? So B to A to E. That's this angle here. Let's stick an X in there or something. You must give a reason for each stage you're working. I'm going to highlight that. You must give a reason for each stage. So every little calculation I do, I'm just going to give a reason. So thinking about this then. Now, one thing not to get confused about, this is not, although it looks like one, it's not an isosceles triangle. Remember, in order for it to definitely be an isosceles, it'd have to have these lines on, like this, somewhere on the triangle, and they're not shown. Now, it may be an isosceles, but it doesn't tell us that it is. So we wouldn't do base angles are equal and stick that over there, or anything like that. We're going to have to use these parallel lines, angles on a straight line, all things like that. So for this question here, we want to get the top angle in that triangle. So maybe we could try and find the 3 angles in this triangle there, or maybe we could look at it as one big triangle and try and find those 3 angles and work out this one down here. It doesn't really matter, there's lots of different ways of approaching this. I'll just go through one way. Now the first thing that stands out to me is the easy mark here is that angle there. So to find that, angles on a straight line equal 180 degrees. Equal 180 degrees, or add up to 180 degrees if you want to write a full explanation. To get to 180 then, we would do 180, take away the 148, that's going to be 32 degrees. So 32, obviously take your time, don't miss out sort of any marks by just doing these two quickly. So it's 32 degrees for that missing angle there. Now you've definitely got yourself some marks, you've worked out an angle and you've given a reason. So can we work out this angle here straight away? Well, it looks like we can, because we have some parallel lines. We've got this one here and this one there, and you've got this straight line passing through the both of them. And hopefully you can see that those two there are corresponding angles. So on the same side of that line passing through, and corresponding angles are equal. So that one there is also 63 degrees, and I put next to that, corresponding angles are equal. And there we go, corresponding angles are equal. And it is important that you write down the full explanation there. You can't just write down corresponding angles next to it, because that's a statement about what the angle is. It's not a reason as to why we've put it as 63. So there we go. Now we have the 3 angles, or the 2 angles in that triangle there, with just one missing. So the final stage of our working out would be to add those 2 together, because this angle here, we know that angles in a triangle equal 180. So angles in a triangle equal 180 degrees. So if we add those 2 together, let's do it down here. So 63 plus 32 is equal to 95. And then we do the 180, take away the 95, and that would equal 85 degrees. So our final answer in this question is 85. If we've got a dotted line, we'll put it down there. So 85 degrees for this question. And there we go, that's how we'd approach that. And it is absolutely fine to label the diagram and stick the arrows sort of pointing up for your reasoning so it's understood exactly what you're on about. You can do sort of a more bullet pointed reasoning down the bottom, but not everybody likes to do that. So I've gone with this method here. But of course, if you like to write the decimals, bullet points down the bottom and actually say each stage as you're doing it that way, absolutely fine. So for example, that 32, where we found that, you could say angle ABE equals 32. Down here as a bullet point, because angles on a straight line add up to 180 degrees. So that's absolutely fine. Okay, so finding the lowest common multiple of 2 numbers. So when we're finding the lowest common multiple, that obviously means we are looking at their times tables. We're not drawing anything to do with factors here. So we're going to write out the 24 times table and the 56 times table. It tends to be that we don't have to go too far normally, because obviously it would take ages, particularly with 24 and 56. And the chance of making a mistake, particularly on a non-calculator paper, is quite high, so we don't tend to have to go too far. Either way, I always draw 4 multiples on each, and then I just keep going with each one. If I draw 4 multiples on each, I'm going to get myself some marks. So 24, add 24 is 48. Add another 24, well, add the 4 is 52, so 72. Add another 24, that'd be 96, and add another 24, that'd be 120. I'm going to do a couple of the 56s. So 56, add 56, 112. Add 6 is 118. Add the 50, 168. Do another one, 174 plus the 50 would be 224. I've done 4 on each, so I'm going to go on the 24 and just really hope that it's one of those ones. Otherwise I'm going to be sat here for ages. So 120 add 24 is 144. Add 24 again, 168, oh, there we go. So thankfully, 168, there we go, came up in both. So, good little tip there, obviously just writing 4 of them, and just hoping that one of the smaller numbers comes up within those 4. But don't give up if it doesn't, make sure that you just write another few on the other one, and just keep going. But there we go, our final answer, the lowest common multiple is 168. Okay, so in a bag there are only red counters, blue counters, green counters and yellow counters. And we can see that down here, red, blue, green, yellow. A counter is taken at random from the bag. The number of blue to the number of green counters is 3 to 4. Complete the table. So blue to green is 3 to 4. I'm just going to label that here, blue to green, which is left to right, the same order in the table. So we know that all these numbers in the table have to add up to 1. Okay, because they are the only colours in there. So what do we have at the moment? Well, we've got 0.4 plus 0.25, and that currently is 0.65. So making sure that you add these up and take it away from 1, because you've got some method marks there. So take that away, and that equals 0.35 that's left over. So what we have is 0.35 that we need to share in the ratio 3 to 4. And to share that in the ratio 3 to 4, it's obviously not very nice written as a decimal, so what you could do is you could just change that to 35%, which is what it is, and then just share 35 in the ratio 3 to 4. It doesn't really matter with the decimals, but it does make it look a little bit easier when you have to share a decimal in the ratio 3 to 4. So if I do that, add those two numbers together, that's 7 parts, so 35 divided by 7 is 5, and then 3 to 4 would become 15 to 20. There we go. They're obviously percentages now, so we would need to write those as decimals. So that'd be 0.15 for the blue and 0.2 for the green. And there we go. There it is, shared in a ratio. So just double check that they all add up to 1. They definitely do, because we only had 0.35 left over, and the 0.15 and the 0.2 add up to 0.35. Another way that's quite common that this comes up, it sometimes says something along the lines of the number of blue is twice the number of green. Something along those lines. And if it said twice the number, you'd have to write the ratio yourself, so that would be 2 to 1. And then obviously you'd be dividing by 3 and sharing it out 2 and 1. But you can have the words instead of actually a ratio given, so one's twice the size or one's 3 times the other, that would be 3 to 1. But just a couple of different ideas behind that topic. So the first 5 terms of an arithmetic sequence, -3, 1, 5, 9, 13, find an expression in terms of n for the nth term. So we've done a bit of nth term already, but this is just from a numerical sequence. So -3, 1, 5, 9, 13. Hopefully nice and quick for you at this point, but that goes up in 4s. So this would be 4n. So it's the 4 times table, but this actually goes backwards because our 4 times table starts 4, 8, 12, 16, 20, and you can see again, rather than looking at these two, which isn't too bad, but obviously this one, it's quite easy to see that's going to be 7 less to get to this actual sequence here. So it's the 4 times table with 7 taken away. So our final answer, 4n minus 7, and that'd be the nth term of our sequence. So there we go, second little bit of sequences we've done there. So here we go, one sheet of A3 card has an area of 1/8 metre squared. The card has a mass of 160 grams per metre squared. Work out the total mass of 25 sheets. Now this looks a lot more complicated than it actually is. But it says here, one card has an area of 1/8 of a metre squared. The card has a mass of 160 grams per every 1 metre squared. But one sheet is only 1/8 of that. So really, all we need to know is what is 1/8 of 160 grams. It's just working out the fraction of an amount. To do that, we divide by 8. So 160 divided by 8 is 20 grams. So one sheet has a weight of 20 grams. So that's per sheet, obviously that's 1/8 of the metre squared. Every card is 1/8 of a metre squared, so one card has a mass of 20 grams, or one sheet of A3 card. So where it says work out the total mass of 25 sheets, well, we just need to do 25 sheets multiplied by 20 grams. That's nice and easy for you to do. You can obviously do some column multiplication if you want for that. Don't think you necessarily need to for this one, but you want to make sure you get it right. So 25 times 20, 0 times 5, 0 times 2. There we go. Placeholder, 2 times 5 is 10, 2 times 2 is 4, so 500. There you go, add those together. You've got 500 grams. So there we go, there's our final answer. 25 sheets would be 500 grams. And obviously putting your units with that, there's no units on the dotted line there. So that one there, obviously there's lots of different ways that you could approach that. I think that's definitely the easiest way, although it doesn't necessarily seem like 4 marks for a question like this when you were to approach it in that easier method there, but there are lots of different ways to approach that and some of them take quite a bit of time. Right, so expanding, and we've got some simplifying down there with our laws of indices. So when we're expanding brackets, we want to multiply both of these here by 3, so that'd be 3y minus 6. And you've got these ones that you're going to multiply by 5. So 5 times 2y would be 10y. 5 times 1 is plus 5. And we have a plus symbol in the middle there, so we keep a plus here. Now you just need to collect the like terms. So you have a 3y and you have a plus 10y, or positive 10y. And in total, that would be 13y. And then you also have negative 6 and you have plus 5. Now minus 6 add 5 is minus 1, so 13y minus 1 would be your final answer there. So there we go, 13y minus 1, just being very careful with the symbols. Onto this, simplifying with indices. You are always multiplying numbers in the same way, so 3 times 5 is always going to become 35. Then you have got the similar letters, so you got u squared and a u. Don't forget, there's a little secret power of 1 there that you want to write in, so you don't forget to add them together, because you don't want to write u2, we want to write u to the power of 3, because we have the 2 add the 1. So remembering when we are multiplying, we have the same base letter or base number, we can add the powers together. The next one, we have w4 and w3, so that w, when we add the powers, 4 plus 3 is 7. So that would be 35, multiplying the numbers as normal, and then u to the power of 3, w to the power of 7, where we have added the powers. And there we go, some laws of indices there. Okay, on to some standard form. Right, 1.63 times 10 to negative 3 as an ordinary number. So 1, 6 and 3. The decimal at the moment is, and I always move the decimal upwards to the top here, and then I jump it whichever way I need to. So for 10 to the negative 3, I need to go 3 jumps left. 1, 2, 3. It's going to go down there. Underneath each of those loops, I need to put a 0. So 0, 0, and tidy it up with a 0 at the start. So that number is 0.00163. There we go. And if it was 10 to the power of positive 3, we'd jump that decimal to the right instead of to the left. But there we go. As it turned out, it was a negative power, so we've jumped it the right way. 438,000 in standard form. So 438,000. I want the decimal to go between the 4 and the 3. So that's 1, 2, 3, 4, 5 jumps. So that will be 4.38 times 10 to the power of, and this time it is a big number, so 10 to the power of positive 5. There we go. There is some standard form conversions. Onto our calculations, work out 4 times 10 cubed times 6 times 10 to the minus 5 and give your answer in standard form. Well, numbers are always going to multiply numbers. You could write these out as ordinary numbers first, but it's a quick way. So if we multiply the starting number of both, 4 times 6, that's 24. And then we just take these powers of 10, and as we are multiplying, we can add the powers. So that would be times 10 to the power of, and that's 3 plus negative 5. When you add a negative, it's a takeaway. So 3 take away 5 is negative 2. So that'd be 10 to the power of negative 2. So that there, right, you've got 2 options now, because it says give your answer in standard form. This is currently not in standard form because that there is not between 1 and 10. And the quick way of doing this is just to make that between 1 and 10 by making the number 1 place value smaller, and you just have to make the place, or the power 1 jump bigger, or in other words, incorporating another 10. If we're going to divide 24 by 10, we would have to multiply by an additional 10, which takes that down or up to -1. So again, that's not the only way you can do it. Again, all I did was I made this number smaller and I made this power bigger to balance it out. But you could write that as an ordinary number and convert it back. So 24 times 10 to the -2 is 24, and 1, 2 left would make it 0.24. And then you convert it back, so you need to move the decimal 1 jump right, which is why it was -1. So you can do it that way as well, just depends on whether you want to convert it back and forth over and over, or whether you prefer just to make 24 1 jump smaller, power 1 jump bigger. So our answer in standard form is 2.4 times 10 to the -1. And there we go, there's our standard form calculation. Alright, so this question. There are 240 bottles of drink on a shelf. Each bottle contains apple or lemonade or orange. The bottles are in the ratio apple to lemonade to orange. Apple, lemonade, orange, 5:3:2. Half of the bottles of lemonade and 1/12 of the bottles of orange are removed from the shelf. Work out the number of bottles of apple as a percentage of the total number of bottles remaining on the shelf. So we need to share the total, 240, in the ratio 5:3:2. So 5:3:2, that adds up to 10. So there are 10 parts in total. So if we do 240 divided by 10, we know that every part is 24 bottles. And if we share that out, 5, 3 and 2, apple, lemonade, orange, I want to multiply them all by 24. 5 times 24, you can take your time to work these out, that's half of 10 times 24, so it's 120. 2 times 24 at the end is 48. 3 times 24 is another 24 on top of that, so 52, 60, 72, and there we go. So that's how many bottles there are currently on the shelf. It now tells us though, half of the bottles of lemonade, 1/12 of the bottles of orange are going to be removed. So looking at what we've got there, half of the lemonade, that's the middle one, we're going to take away 36 of those. Okay, I'll just write this over here. Half of 72 equals 36, and 1/12 of the bottles of orange. So the bottles of orange is 48, so we have 1/12 of 48. That's dividing 48 by 12 is 4, so that's 4 bottles that are getting removed. And we're not removing any of the apple. It says work out the number of bottles of apple as a percentage of what's left. So we've got 120 apples still. We have got 36 bottles of lemonade, because that's half of 72. And we are going to have 44 orange, 48 take away 4. So that's how many bottles we have left on the shelf. Work out the number of bottles of apple, which is the 120, as a percentage of the total number of bottles remaining. So if we write that as a fraction, which I'd always do first before trying to get it as a percentage, that'd be 120 out of, and what do all of these add up to? So 120, 36 and 44, add those all up, we have 4, 5, 6, 7, 8, 9, 10 again. So that is out of 200. So that's 120 out of 200. Now to be fair, that's come out perfect, because that, if I simplify it by dividing by 2, straight away that's going to be over 100. So that's 60 over 100, and that is 60%. So that's come out really nicely. So we'd have to do the same process anyway, but because it came out really nicely with 100 on the bottom, that percentage was really nice and quick for us to get there. But there we go, there was sharing in a ratio, and then we were doing fraction of an amount to take away some of those numbers, and then writing it as a percentage of an amount. I think the big tip in that question is when you're writing the percentage of an amount, always write it as a fraction of an amount first. Okay, on to our next question. Okay, so in this question, we've got a bit of a perimeter problem. It says here's a rectangle, 4 centimetres and 10 centimetres, and the 12-sided shape below is made using 4 of those. Work out the perimeter of the shape. So if we're going to work out the perimeter, let's just label some of the 4s that we can see. We've got some 4s there. There we go. Any 10s that we can see. So there's a 10, there's a 10, that's a 10, and that's a 10. And then we need to find these lengths just here, which aren't going to be awful to find, because each one of those is the gap between 10 and 4. So if you think about why that is, let's just have a quick look. So the full length across is 10. This little gap here is 4, so that would have to be 6. Because 4 and 10 obviously add together to make the 6. Sorry, 4 and 6 obviously add together to make 10. So those gaps there are all going to be 6. And then we just need to add them all up. It's very awkward to add. So you could either put it all in one big line, or you could add up all the 6s, add up all the 10s, add up all the 4s. Up to you. If I add up all the 4s, look, let's do it one way. 4, 8, 12, 16. Now if I add up all the 10s, 10, 20, 30, 40. Let's write that down. And now add up all of the 6s, 6, 12, 18, 24. And that is 24. And then add them all together, 6 and 4, 10. 1, 4 is 5, 6, 7, 8, so that is 80. So there we go. So the total perimeter there is 80 centimetres, and there we go. So that was just all about finding that missing gap of the 6, really. You could be given this question in lots of different ways. It would have been interesting to sort of give this question, and rather than doing it like that, maybe they could have given you the height and made you find the numbers. So they could say 10 and 4 and 6. They could have said the height is 20 centimetres, and maybe they could have given you, I don't know, something like this length here. Maybe they could have said that that 4 and the 10 was 14 centimetres, and got you actually to figure out those lengths yourself. But there we go, just a sort of difficult version of that question maybe, but a different way of sort of approaching a little bit of a relatively nice perimeter problem there without having to find too many missing lengths. Okay, on to some exact values of trigonometry. We've got write down the exact value of cos 60. So in these exams here, obviously we know that sine 30 and cos 60 are our two really important ones. Cos 60 is just a half. You could write that down as a half or 0.5. I wouldn't write that exact wording on the dotted line, I'd just write one or the other. So I'd just put 0.5, okay, or put the half, it doesn't matter, both of those are going to be fine, but 0.5 is the value of cos 60. For part B, it says given that sine 30 is 0.5, so give us our other value there. Remembering that you could be given any decimal here, so I'm going to use an approach as if any decimal was given, work out the value of x. So we know it's going to be sine, otherwise they wouldn't have given it to us, but there's the opposite, and there's the hypotenuse. So I'd normally just write down my formula triangle, SOH, and figure out is it a multiplication or a division. To find the opposite, that's a multiplication, so you do S times H. So it's 0.5 multiplied by 12. When you multiply by a half, it does halve the number, so that would be 6 centimetres. Although to be fair here, x is given to you in centimetres, so you wouldn't need to put centimetres with it, but I don't think you'd lose any marks there if you wrote 6 centimetres rather than 6. So there you go, that's how you'd approach that. Obviously, if this decimal wasn't a nice one, like 0.5, then you'd have to hop the decimal out, do your normal multiplication method. So in this case, it would be 12 times 5, which is 60. Hop the decimal back in, 6.0. But we know when we're multiplying by a half, it halves the number. So that's a nice quick one to do. So there we go, there's some exact values of trigonometry. And then we have some speed, distance, time. So Salma drove from London to Birmingham. It took her 3 hours at an average speed of 80 kilometres an hour. Carl drove from London to Birmingham. He took 5 hours. Assuming that Carl drove along the same roads as Salma and did not take a break, work out Carl's average speed from London to Birmingham. So we know that speed, distance and time are related in our way using our formula. Okay, and sometimes on a non-calculator paper we'd take a different approach, but let's just have a look. So Salma drove from London to Birmingham. It took 3 hours at an average speed of 80. So we have the time and the speed. So when we are working out a distance, which is all we can work out from that, we multiply the speed multiplied by the time. So the speed is 80, the time is 3. So for 80 times 3, 8 times 3 is 24, add the 0, that's 240 kilometres. So that there is the distance that Salma drove. She drove 240 kilometres from London to Birmingham. It says Carl drove from London to Birmingham. He took 5 hours. Assuming that Carl drove along the same roads as Salma and did not take a break, work out Carl's average speed. So if we assume that he drove along the same roads, then we're assuming it's the same distance, but he took 5 hours. So again, if we think about our formula, speed, distance, time, because we're working out speed now, that would be distance divided by time. So our distance is 240, the time is 5 hours. So I'd need to do 240 divided by 5. Again, if you're not 100% sure on that, you can do lots of different things. We could do some bus stop, we could times the top and bottom by 2 and do divided by 10. That's a nice way. That's not going to work with every number perfectly like that, so I'm going to use bus stop division. 240 divided by 5. 5 goes into 20 4 times, remainder 4 goes into 40 8 times. So that's 48. That was an average speed, so that's 48 kilometers per hour, and that makes a lot of sense. If Salma in this question was driving at 80 kilometers per hour and did it in 3 hours, and Carl took 5 hours, it would make sense that Carl was driving slower than Salma was. So 48 kilometers an hour. Part B, if Carl did not drive along the same roads as Salma, explain how this could affect your answer to part A. Well, if Carl did not drive along the same roads, then this distance here could have been bigger, could have been smaller. And if the distance was bigger or smaller, then the speed could be higher or lower. So if Carl did not drive along the same roads, explain how this could affect your answer to part A. Okay, the answer to part A, which is the speed, could be higher or lower. I think the important part there is it's higher or lower, because technically if they didn't drive along the same roads, the distance could be shorter, the distance could be greater. It's not told us either or. So depending on which of those it is, the answer could actually be higher or lower. And there we go, and that's the end of that paper. So as I said at the start, don't forget there are lots of topics that can come up on a non-calculator paper. Hopefully this just gives you a good bit of practice on some non-calculator topics, particularly with things like speed, distance, time and exact values of trigonometry, which obviously having trigonometry and speed, distance, time on a non-calculator paper isn't the nicest, but hopefully this gives you some practice and some topics to think about in terms of your revision. As I showed you at the start, you can go into the description, you can find the full lessons on any of these, and obviously make sure that you follow along for paper 2 and 3, because across the 3 papers, that is where we are going to cover the large majority of topics that can appear on the GCSE. So for example, a lot of the topics on this paper, it might be that when you sit your GCSE, a lot of them maybe appear on paper 2 or they appear on paper 3. But the important part is that prior to that, you've had a good practice and a good coverage of a lot of those topics. So there we go. Hopefully you found that useful and helpful. Don't forget to subscribe to follow along with the rest of my videos and the rest of my upcoming videos for your GCSE. But hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe. And I'll see you for the next one.